Hello everyone. So thank you for watching my lecture video. So this is about a sample problem from 201 to 210. Okay. So for this problem, what we wanted to find is the probability that a family visiting a park has exactly 6 members. So we want to find this probability, like then we have number equals 6. So giving that, so there's a condition probability. Giving that, so exactly 5 member of we 5 member exactly the 5 members of family ride the lower cost. So okay, so we just check this condition first. So what is the probability that is this? So we have 5 members of family ride those things, like play these games. Okay, so let's say so the family size can be 1, 2, 3, 4, 5, 7, 6, 7, right? So we let m is same family size. Okay, so this m can be 1, 2 until 7, right? And the probability of fraction, the probability is just the a minus m over 20a. Okay, so we have members family member size. Okay, so let's say we have 5 members of family ride the roller coaster. So this m should be like we have like okay, this is just the m equal 5. So then all the 5, so we say m can be just a 5, 6, 7, right? We have this 3 cases. So if m equal 5, so there's a probability is a minus 5 over 20a, and then all those 5 just play the game. So this probability is what? So if the family size is m, then the number of people will do these things follow uniform distribution. So just equal like or like if so there's m can be like 1 2 m, so the uniformly the meaning is evenly. So each case is 1 over m. So this is if we have 5 people, so 1 over 5, right? The probability 5 people play this. And then we have 6 people, family size 6. Then among the 6 people, there have 5 people will play the game. So such a probability is 1 over 6, 1 over m, right? Okay, so then here's 8 minus 7 over 28, so 1 over 7. So this is total. So this is condition. This is the condition. So we just find like this part. This is family size 6 member. This part count for how much for total, right? So just this over. So the probability is just this over all. So probability is just this. This part, let's say 2 over 28 multiplied 1 over 6. So over total is okay, 3 over 28 multiplied 1 over 5 plus right 2 over 28 multiplied 1 over 6 plus 1 over 28 1 over 7, right? So this is the answer. Okay. So for these problems, we can cancel. Maybe we can make it simpler. We can cancel 28 here. 28 cancelled. Okay, and so this is just let's see. So then just do some calculation. Simplify the here is just 2 over 6.5. So this is 2 over 7.5, and this is 3 over 5, 3 over 0.6, right? And for this one, 1 over 7. Okay, so then just calculate here. So for this problem, okay, so we have like a students loan and some people have car loan. So this just have two facts. So we just use a Venn diagram maybe. Okay, so let's say, so we just use this like, okay, student loan. So this is for students loan. That's for students, and this is for car loan. Okay. Okay. So we say that students count for 30%, right? 30%. Okay. So let's say check this condition. So this is among those column, among those 40% student loan. So this means like so if so we put this like so if this is 40%, yeah. So here's 0.4x. Okay, and here's 0.6x. Okay. So then check this condition. Okay. Of the borrowers who did not default on any student loan, 20. So among those, 20% has come. So here, just like conditional probability. So for those, among those, so totally those, not, okay, so, okay, so did not default on any student loan. So student loan is 0.3. So not is I think it's 0.7, right? So among those, 20% column. So this count for like 0.4x. So this equal 28%. Okay. So we can solve for x, right? So then once we have this x, so we can find this. So we have all the information here. Okay. So what we want to find this probability that the selected borrower default on at least one column. So just find x. We don't want to find this x, right? Let's see. Oh, I made a mistake. Okay, here. This should be, let's say, 0.6x. Yeah. All right. Let's see. So here should be careful. 20% is at least one column. So so it's just this part, right? Okay. So let's say, yeah. So 0.66 equal 0.2a multiply 0.7. Yeah. Okay. So we can find x. So for this problem, we want to find these conditional values. So conditional values, so we need to find conditional density function or conditional distribution. So let's check out y when x equal 2. So the density function, we just plug in x equal 2. So there's a density function. The conditional density function is just when we put x as 2. Like 1/6 thing multiply 1/6y, yeah, and x is 2, so just negative 2/3, not 2/6, yeah. So this density function maybe is not this conditional density function, so maybe the total probability is not equal 1, right? So we need to adjust that. So we say, so this is just a constant, so this just equal some constant multiply this. So we know this y, this y just follow exponential distribution, should follow exponential distribution, right? And the lambda is 1/6, okay? Lambda, yeah, okay. So variance of y is just 1/lambda square. So this equals 36. Okay, so for this problem, we want to find the probability that this time, time between this and this is less than 4. So we want to find such things like the time less than 4. We want to find this probability. So what is this time? So what is this? Suppose this is t. Okay. So this is t. Let's say there's t. What is the distribution? There's t. There's a distribution is this. Okay. Oh, okay. I'm sorry. This t is not between here to here. This is not so simple. This t is, let's say, between occurrence and report. So here stored just like that, occurrence and report. So this is t. And so, and for giving t between reporting and payment. Yeah, so here's the payment. This another t. Suppose that we can find this. Suppose there's a t. This is another t, another time. So suppose there's a t1, t2 like this. So what do you want to find? this is actually left time between occurrence and payment. So this actually, this time is equal T1 plus T2 less than 4. Okay, P1 plus P2 less than 4. Yeah. Okay, so how can find this probability? So we need to do this. Let's say the only conditions giving this is let's say this is T1 giving T1 equal T. So we know this. Okay, this is uniform. So let's say, so for this probability, so we let the T1 change. So let's say it's equal. We just say summation. Let's say probability T1 equal T. Then under this condition, T1 equal T, then T2 plus T1 less than 4. So this T1 is continuous distribution. So then this summation become integration. Okay. So this equal, let's say, so this T1 equal T is this, right? The density function AT minus T square over 72. AT minus T square over 72. Okay. Then what is this probability? So here T1 is fixed. T1 equal T. So this become like a T2 less than 4 minus T1, right? So here T1 is a constant. Just a T. Yeah, T1 is a T. So T is fixed. So T1 follows which distribution? T2. So here T2. This is T2. Yeah, reporting to payment is T2. So this T2 follow uniform distribution between 2 plus T and 10, right? Okay, so what is the probability T2 less than 4 minus T? So here's 4 minus T. Okay, so this probability is equals this, right? So totally is A minus T, right? 10 minus 2 plus T, A minus T. And the saying this part, 4 minus T to 2 minus T, yeah, 4 minus T, yeah. So minus, let's say 4 minus T minus 2 minus T. So just 2 minus 2T. Right? Okay. So then this, so add them up become integration. T. So there's T from, let's say, there's T can from 0 to 6. So T equals 0 to 6. Okay, yeah. So now we just do some this integration, just simplify, right? So and we can A minus T, so if T cancel, this equals a simplify. So here 72 and over 2 we can take it out. So this is T, this is 1 minus T, right? dt. So for this problem, is we want to find calculate this probability W less than 79. So we can say that this equal this two part is 0, so this equal t between 0 to 1.5 or between 10 and 8, right? So plus so t is between 1.5 to 8. So this become like a W become 100 thus. So less than 79. Okay, so for this t, let's say t follow this uniform distribution. T is from 0 to 10. So this part probability is so here 10. So here's 1.5, here 2 is 3.5, right? Okay. So then we just need to find this probability. So this one, so we need, there's two conditions. One is t less than 1.5 to a. Other one is like negative 0.004 t less than thus. Okay. So for this one, we solve for t. We find t should larger than 0.004 over ln negative ln 0.79. Okay. Okay, so this probability, let's say, so t between this also, so let's say, okay, okay, so this t suppose, okay, so between, so this 8 and also this number. Okay, so the probability for this part equal, so this equal, let's say equal, so this one, we put this a, so this one equal, so just this thing is 8 minus this, like 8 this minus this, so it become 8 minus this, so become 8, so negative minus, so become like this, right? Okay, so use a calculator to find this number, so we can find this probability. So for this problem, we want to calculate the ratio of standard deviation of this policy payout to the standard deviation amount of damage. So here we have two things, damage and payment. So this damage, So this is a damage. Suppose this is x, right? X is from uniform distribution from 0 to b. Okay, so let's say payment as y. So this y is, we have deductible. So just like let's say, so here's 0, here's b, and this deductible is b over 10. Okay. Okay. So let's say the payment. So we just find standard deviation of the damage. So damage we just find standard deviation. So we just find Vx. Okay. Values for x. So because x follow uniform distribution, so we know values equals us 12. So this minus the square, so b square. Okay. So for repayment, that's Vy. So we need some calculation. So Vy equal y square minus square of y. Okay, so here let's calculate, right? So what is y? What is y square? So y equals us, like y equals 0. We forget the y is from deductible b over 10 to b is x minus there's a deductible. There's a payment, right? Okay, so then density function is 1 over b dx. So this integration, so use substitution. We just say x minus b over 10 equal t. So this will become like a t dt, and take a b 1 over b other side. So here's 0 and then 9 or 0.9 b. So we can easily find this equal 2b, b cancelled, so that's just the half of 0.9 square and b. Okay, and for so same way we can find y square. So y square just becomes thus. Okay, 0.9 b. Yeah, so here's t squared dt. So equal, we can say this equal 1 over 3. So cancel 1 b, so here's 0.93 and b square. Okay, so what is Vy? So Vy equals this. So we can take a b square, or maybe you can forget it as a b square because this is ratio, right? So b square, so this equal 1 over 3.93 minus 1 over 2.9 square. Okay, so the ratio is just so the ratio is which or which. Yeah. So this is payment over the Vy over Vx, or take square root. This is a standard deviation, right? So we just check, let's say, so Vy over, so Vy over Vx, so equal, so here equal 1 over 12. So here just like that, right? We can put this 1 over 4.94. Okay, then take square root. Yeah, so the answer is take a square root of this, right? So it become standard deviation. So for calculation, maybe we can simplify a little bit. We just multiply 12, right? So this just become 4 times 0.93 minus 3 times 0.94. So the answer just equals this numbers take square root. Okay, so this problem is we say f equals all the things, g equals all the things. Yeah. So the question is, what is f and g? So such a problem is easy. Like so, f equals s has exact 1, and g and has 1 or more in 1, 2. So this is just put them together. In year 1 have 1, right? Like year 1 have 1, and year 2 has 1 and at least 1. So just certify both of them. So we just check which one certifies this. So for this problem, we want to find the probability. So here, so the question is a probability question here. Calculate the probability of giving that. So this is also conditional probability. Yeah, giving that. Okay. Or next thing, giving that the giving that the polyhold is a high risk. Okay. So let's say, so the question is information is too much, so we should be patient. Okay. So at first we say we separate or categorize or separate the all people, all polyhold into 3 groups. High risk. So we just separate this into high risk, mid risk, medium, and low risk. Okay, so they are count for let's say count for 20% and 35% and 45%. So we just separate them into percentages like that. Okay, so the probability of death of next year. So different group have different probability for death for next year, right? So we say like if the high risk for those people, for those high risk people, is 2 times the probability for middle risk. So we just put if this p, then this is 2p. Okay, right? And so for those middle risk one is 3 times the probability for death of a low one. So if this is P, then low one is just 3 times. Oh, we just say this is 1 over 3P. Okay. So we want to find this P, maybe. What do we want to find? We just want P. Yes, so this probability, giving that for high risk. We just want to find 2P. Giving that the policyholder is high risk. So we want to find 2P equal what? Right? Okay. So let's say what the condition. So how to find the P? So this is the probability for death for over next year is this. So here, this is for all people. So we just check, okay. So this 009, this is probability calculated this way, right? So this is the probability for death for next year for all people. So we need to check for each part. So for this part, for high risk, count for 20% of 0.2. So multiply 2P, right? So plus 0.35 multiply P plus 45%. Same for them, 1 over 3P. So solve this equation. We can simplify this 0.4P, right? And this is 0.75, and this 45 divided by this become 0.15P. So we can find P equals 001. Okay, so the answer is 2P, 002. Okay, so for this problem, we want to find the deductible. We want to find this deductible D such that once we have the D, we have the deductible, the expected payment is 30. Okay, so here of course the story quite is the same. So payment, so payment is after the deductible, right? Okay. So let's say the damage or cost, we have this case that we have a problem with, we have 3 problems. Like we have switch, or we put these 3 parts, like so cost. This case is the switch. So probability is 10, cost is $60. And the problem is this. The problem is this pilot. So this probability is 0.005, and the cost is $200. And so the problem is this, and the cost is 3,000, and the probability is 0.001. Okay. So we can say that deductible should be more than 60. No, more than 60. Because like this is almost 300, too much. Okay, so we say the deductible, so we can find this payment is Y is payment. Oh, payment. So equal. So we can forget this, right? Should be like 0.05. So by another 200 minus D. So plus 0.01. So 3000 minus D. So we let this equal 30. So we can find it as D. Right? So we can easily find it D equal. Okay. So for this problem, we found a probability. Yeah, we found a probability that at most one is insured. So we just let's say okay, damage 3 house. So totally we have 10 house. So for this 10 house, we just split it into two parts. Some are insured. So K not insured. So 10 minus K insured, right? So here, this is insured. So here not insured. We just split all into parts. So from here, damage randomly the damage 3, so just from here pick 3. Okay. Pick 3, so we want to find the K, yeah. So once we find the K, then we can find the probability. So at the first we need to find the K. So how can we find the K? So we just check this condition. This is none of damaged house is insured is this. So just so such a probability is just from 10 we just pick 3, and there's 3. None of them is insured. So this 3 is just from the K choose 3, right? So such a probability is 1 over 120. So from here we can find this is K. So we just solve this equation. So K, so this equation become K times K minus 1, K minus 2. And here is 10 times 9 times 8. So we let this equal 1 over 120. So 120 we can put this 10 times 3 times 4, right? 3 times 4. So we can cancel, we can find this K. Okay, so it becomes 3. Okay, so anyway, like solve this K is easy, yeah. Solve this K. So just like K times K minus 1 times K minus 2 equal 1 times 2 times 3. So we find this K equals 3. So once we find this K, then the problem is easy. So let's check what's the question. Question is we want to calculate the probability that at most one is insured. At most one, at most. So at most, so we just use this. At most one is we just consider opposite, right? So that's equal 1 minus opposite is none of them is insured. So there's a probability from here pick 3, and none of them is insured. So all are not insured. So just from like 3 choose 3. Okay. At most, it. Oh, maybe I'm sorry. At most is just the this is just the number of insured 0 or no, or 1 insured. Yeah, so 0 insured. This is long. So this equal actually is so 0 insured. 0 insured is 3 3. Yeah, and then plus 1 insured. So 1 insured is from this not insured we pick 2, from insured pick 1. Yeah. So here just be careful. So at most 1 is insured, so means 0 insured or 1 insured. Yeah. Okay, so there's a problem from 201 to 210. So we can stop here. Okay. So thank you.